Who believes this? Go home and check it. Put in three vectors and add them up this way, and add them up this way, you'll get the same. If you follow this geometrically. If you follow this geometrically. So now the mathematicians are what? They're puzzled. What are you doing? How do I put some numbers here? Right? Yes. Mathematicians we want to really get our hands around this thing. Okay, well, you're doing some geometry, no doubt. That is 100% kosher. I want to talk about this mathematically and translate that and say that it's consistent. So instead of doing the geometry of vectors, we do what? Algebra. The algebra of vectors. So let's just say, let's just keep it in two dimensions. Yeah, let's keep it in two dimensions. And I could draw the vector here, or I could draw it here. Which one is easier to visualize? This one. So we could here's a vector. Which the physicist is entirely happy with. The physicist, what are you doing here putting this grid here? I know what I'm doing. So, okay. It's for my own friend, because I don't know this. And then they will say, well, how about this vector here? And then you say to the physicist, well, now let us talk about this scalar multiplication. You take to the physicist, hey, physicist guy, you take this vector u, and if you multiply it by 2, what are you talking about? He will tell you what he's talking about. I'm talking about this vector here. And if you say to the physicist, if you take that vector and you scale it, you shrink it by 2, what vector are you talking about? What are you doing? I'm talking about this vector here. What does the mathematician do? Hold on a second. This is 4 along and 1 up. And this is
8
along and?
2.
Hey, the numbers are. I'm getting some numbers around this thing. And the same here. This is 4 along and 1 up. This is?
2 along.
And? The mathematician said there's no way to get numbers involved here. Clear. Let's talk about the addition. So, the physicist says, yes, we all agree that that is u. And we all agree that that is v. Now you say to the physicist, well, now add them up. I'll do it for you. What I do is I move along here and then I bring this one here. And then I get my result. Any problem, sir? Oh, no problem. Let me think about that. This was how many along? And this was how many along? This is how many along?
6.
Oh, the numbers are cranking out here. Right, Mr. Collins? 6. This is how many up? And this is how many up? This is how many are. I see some nice algebra here. Do you agree, Mr. Breda?
Yes.
Let us see it. So the physicist, the mathematician is going to say, let us do some algebra here. Algebra of x. The mathematician is going to say this is what vector. Four along and one up, which is not a coordinate. Okay, because we can't add coordinates, add vectors. So I do not say it's a coordinate. Four along and one up. If you don't like that, you can write it like this. Four along and one up. If you don't like that, then what I want. Just to mess with this, Christina. Four along and one up. So, depending on who you talk to, we'll use one of them. Oh, some people have other ways to talk to you. Huh? I'm sorry?
The I, the dot. Use a caret.
Oh, yes, some people do that. You're right.
Yes.
Yes, yes, yes. And what is the vector b? Huh? Two along and?
3 up.
3 up. 4. 2 along and 3 up. 4. 2 along and 3 up. Now the physicist is talking about that vector. Here. He says, I'm talking about that creature there. Do you see that it has a magnitude? I say yes. Do you see that it has a direction? I say yes. Different from that direction. He says, what, Mr. Breda? Where is it here? Now you got me. All right. Now the physicist got me. He's twisting my arm. He says, man, I'm clear. For all this is a vector, it's got that magnitude, and it's that direction there, not that one, that one. And you say what, Mr. Breda?
I mean, the direction could be a ratio between those two.
It's in there. 4 along and 1 up, not 4 along and 4 up. Just to say the direction is embedded in that information here. It's there. You just don't see it. But it's there. The direction is there. 2 along and 3 up, not 3 along and 4 up. Okay. Keep it in the piece now. But where's the magnitude? And you say what, Mr. Harris? Do you know the Pythagorean theorem? 4 along and 1 up, 4 squared plus 1 squared. You take the square root, is the square root of 17. Oh. Good. I don't know the Pythagorean theorem, this will tell you, but I'll take your word for it. That is to say, the direction and the magnitude are embedded in here. Not 4, not 2, 4, 6 would be twice the magnitude. So now the math physicist says, okay, you are doing exactly what I do, but you are speaking a different language. But it appears that we are consistent. Clear. So, and won't you talk about any old vector? What vector, Mr.
U vector?
Yeah. Now I'll use A and B. And V. Huh? Do you all agree? Or if you want, you can write it like this. We want to do what with this thing? Scale it. So take this and multiply it by a number alpha. What is alpha u, Miss Christina?
Alpha is the constant you're multiplying by?
Yes. What is that? Vector. Take that vector and multiply it by alpha. And here, if I go 1, 4 and I multiply it by 2, I end up with 1, 4. If I stretch it twice, huh?
8, 2,
8, 2. That is, I take the components and multiply them by. Who's lost? Raise your hand. Alfonso. That's how the mathematician does it. And he says to the physicist, trust me, it works. Clear. What be this?